Astronomers working with South Africa's highly advanced Meerkat radio telescope have recently made an extraordinary detection. The first recorded radio waves coming from the interstellar comet 3I/Atlas. While at first glance this discovery may sound mysterious or even hint at something engineered by an extraterrestrial civilization, scientists clarify that the signal is actually further confirmation of the comet's entirely natural origins. The comet, known scientifically as 3I/Atlas, is only the third interstellar object ever observed passing through our solar system. Its arrival has generated a great deal of excitement among astronomers, not because it might be an alien spacecraft, but because interstellar objects carry information about stars and planetary systems far beyond our own. These visitors can offer rare insight into how other solar systems evolved, what materials exist in distant regions of our galaxy, and how debris travels across interstellar space. The comet was originally detected in early July as it hurtled toward the inner solar system at a tremendous speed of more than 130,000 miles per hour. Later, researchers found earlier archived observations dating back to May, which helped them better understand its trajectory and physical properties. Based on multiple lines of evidence, most experts agree that 3I/Atlas is a genuine comet, possibly even one of the oldest of its kind ever observed. Scientists believe it was ejected from its original star system billions of years ago, during the early formation of the Milky Way, and has been wandering through interstellar space ever since. Despite the strong scientific consensus, a small but vocal group of researchers, most notably Harvard astrophysicist Avi Loeb, who has gained public attention for his interest in alien technology, suggested almost immediately that 3I/Atlas might be an artificial object. According to this fringe theory, the comet could be an alien spacecraft disguised as a natural body or perhaps equipped with some sort of advanced propulsion system or communication device. Supporters of this idea pointed to the object's unusual speed, its interstellar origin, and the general mystery surrounding such rare cosmic visitors. However, these claims lacked concrete evidence, and most astronomers warned that such speculation drew attention away from the real scientific value of studying the object. This situation is reminiscent of what occurred with the first interstellar object ever detected, a cigar-shaped object called Oumuamua. After its discovery in 2017, Loeb and others publicly speculated that it could be an alien probe or a fragment of extraterrestrial technology. The idea made headlines and fueled countless conspiracy-style discussions, even though follow-up studies strongly supported a natural explanation. Many astronomers expressed concern that these sensational interpretations overshadowed careful scientific analysis. With 3I/Atlas, the same dynamic seemed poised to repeat itself as the comet approached its closest point to the Sun, known as perihelion, on October 29th. When the Meerkat radio telescope team revealed that they had detected radio emissions associated with the comet, some proponents of the alien hypothesis eagerly anticipated what they assumed would be proof of extraterrestrial engineering or purposeful communication. Instead, the actual findings demonstrated the opposite. The signal detected was not artificial at all. It was the unmistakable signature of hydroxyl radicals, simple molecules made of one oxygen and one hydrogen atom, produced naturally as the comet interacts with sunlight. These hydroxyl radicals form when solar ultraviolet radiation breaks apart water molecules released from the comet's icy surface as it warms near the Sun. This process, known as outgassing, is one of the defining behaviors of comets. When a comet gets close enough to the Sun, frozen materials buried inside it begin to vaporize. These gases then escape into surrounding space, creating the coma, the fuzzy halo that surrounds the comet's nucleus. As water molecules within this coma break apart, the resulting hydroxyl radicals absorb and emit radio waves at very specific wavelengths. These radio signatures have been studied in other comets for decades. What Meerkat detected from 3I/Atlas was exactly the same type of natural signal seen in countless other comets within our solar system. This detection is extremely important because it directly confirms that 3I/Atlas contains water ice and behaves like a normal comet when heated by the Sun. Earlier in October, NASA instruments had already captured spectacular evidence of water erupting from a comet like a fire hose under high pressure. That alone provided strong proof of natural activity. But the new findings from MEERKAT reinforce that the water molecules in the comet's coma are undergoing the expected chemical reactions caused by sunlight. Far from being an anomaly or an artificial device, this behavior shows that 3I/Atlas is following the same physical laws that govern every comet we have studied. Hydroxyl emissions are so reliable that they are used by astronomers to estimate how much water a comet releases over time. So finding these signals in an interstellar comet is another confirmation that the building blocks of planetary systems, even those far from our own, share common ingredients. Moreover, the radio waves detected are very faint, diffuse, and spread out across the coma, which is exactly what would be expected from natural molecular processes. Technological signals, by contrast, would typically show patterns like narrow frequency bands, repeating pulses, or structured modulation. No such features were present. Instead, the data matched perfectly with natural cometary chemistry. Astronomers involved in the observation emphasized that there was absolutely no indication of intelligent origin. Every measurement pointed to the comet being a simple, ancient fragment of ice and rock, shaped by billions of years of cosmic travel. 3I/Atlas provides a unique opportunity for scientists to compare comets formed in another star system with those that originated in our own. By studying the composition of its ices, the behavior of its dust, and the structure of its coma and tail, researchers can test theories about how planetary systems evolve and how materials get distributed throughout the galaxy. Interstellar objects like this one are extremely rare, and each brings with it a chemical fingerprint of the environment where it formed. If the comet truly originated in the frontier region of the Milky Way, an area where stars are older and conditions may differ from the parts of the galaxy closer to us, then it carries valuable information about the early history of our cosmic neighborhood. Scientists hope that continued observations, including spectroscopy and thermal measurements, will reveal what types of ices are present, how old the object is, and whether its composition resembles comets from our own or cloud. The public fascination with extraterrestrial technology is understandable, but astronomers emphasize that natural explanations are not only more likely, but also far more scientifically meaningful. Each time an interstellar object enters our solar system, it offers a rare window into distant star systems. Mischaracterizing these visitors as alien spacecraft distracts from the remarkable scientific opportunity they represent. In the case of 3I/Atlas, the discovery of hydroxyl radio emissions is a milestone, not because it hints at alien communication, but because it allows researchers to confirm that the same basic physics and chemistry operate across vast distances of space. This strengthens the idea that planetary systems throughout the galaxy may share common origins and follow similar developmental pathways. In the coming months, 3I/Atlas will continue on its one-way journey out of the solar system, never to return. As it travels outward, it will gradually become too faint to observe, leaving astronomers with the data they gathered during its brief visit. That information will be analyzed for years, helping scientists refine models of interstellar comets and improve predictions about how often such objects may pass by. The excitement surrounding 3I/Atlas serves as a reminder that the universe is full of ancient travelers, each carrying a piece of the story of how stars and planets form and evolve. And while imaginative theories about alien spacecraft may capture headlines, the real story, the story written into the ice, dust, and molecules of interstellar comets, is far richer, more complex, and ultimately far more astonishing than fiction.